Okay, let's look at question 1 and see if we can work out the solution. We've got a smooth wall, a ladder resting against it, and we have some friction here from carpet, which creates a vertical and a horizontal force. We know that the horizontal force is actually in reality back this way, pushing the ladder back towards the wall to hold it in place, but we're going to draw it in this direction because that's convention, to draw it in the positive direction, and we expect it to come out negative in the equation. So let's see how we can work out whether or not this equation here is correct. We know we've got something in terms of W, something in terms of V, and something in terms of H. So we've got to use W in the equation and V in H, which means our pivot point must be up here. If our pivot point was anywhere else, we couldn't use W or V or H in the equation because we know that any force through the pivot point has a zero moment. So if we take our pivot point at P, let's work out the moments around P. Should I just make that? Let's work out the moments around P. The moments around P, well, first of all, we know that W is acting at the center of this beam, of this ladder, because it's a uniform weight. So we know that this distance along here will be 1.5. So we know that that's working at 1.5, and if we take the line of action of this weight W, we can see that the perpendicular distance of that back to P is 1.5. So the moment due to W would be 1.5 times W. Okay, that's the first part of our equation, looking good. And it's, let me see, around P, that is in the negative direction. So it's in the clockwise direction. Yes. So in actual fact, that will be a negative. Let's keep going and see what the rest of the equation is saying. So let's see what V and H are doing. Around P, this is V, this is the line of action of V, of our vertical force through here. And its distance back to P is down here, we can see it's 3 meters. So the moment due to V is 3 times V. And because it's in that direction, it's in a positive direction. Right, so let's see what the moment due to H is. So once again, H is along this line of action, which has a perpendicular arm back to P, that's 5 meters long. So the moment due to H will be 5 times H, and because it's in this direction, it's a negative. Oh, sorry, because it's in this direction, it's positive. So we leave it positive. So that's the equation. And because this system is at equilibrium, we know that the sum of moments is always 0. So if we look at this equation here, we can see that it's actually the same as this equation here, where everything is multiplied by -1. So we can say that equation is correct.